Hello viewers, welcome to Economic Wise. Today we are going to look at macroeconomics and it's going to be a continuation of what we've started, which is the IS curve. Now what we'll be looking at today is the algebraic derivation of the IS curve. That is, we want to derive the IS curve mathematically. But before we proceed, it is worthy to note that the IS curve shows the various combination of interest rates and national income at which the goods market is at equilibrium. And we say the goods market is at equilibrium when aggregate expenditure is equals to the national income. In other words, the total goods and services produced in the economy is what sold. So this is just a diagrammatic representation of the IS curve. It just looks like the aggregate demand curve. It's downward sloping. In other words, the interest rate and the national income moves in opposite direction. The higher the interest rate, the lower the national income, and the lower the interest rate, the higher the national income. Now, in an open economy, the aggregate demand in such an economy is equals to C plus I plus G plus NX, and the aggregate demand is also equals to the national income. So our AD here is equals to C plus I plus G plus NX, and C can also be written as A plus BY. That is, our consumption is divided into autonomous consumption and induced consumption. I here stands for in total investment. This is autonomous investment, and this D here tells us the change in how investment respond to changes in interest rates. The G, X, M, and T all represent autonomous components of their respective variables. Here we are going to fix in the substitutes of C, I, G, and NX. C here can also be written as A plus BY. I here can also be written as I naught minus DI. The G here can also be written as G naught, and NX can also be written as X minus M naught. So by opening the brackets, we have what is here. And also, we are going to collect like terms by bringing the variables with y to the left hand side and leaving all other variables on the right hand side, which is what we've done here. Factorizing y out, we are left with 1 minus b in the bracket, and we still have the same thing on the right hand side. So to get the value of y, we have to divide both sides by y minus b. Then this y minus b can cancel this y minus b. So we'll be left with a plus I naught plus di plus g naught plus this over 1 minus b, which is what we have here. So we can now separate this by bringing all autonomous components together and taking the one with the interest rate separately, and that is why we have this here. Now if we assume all autonomous components to be equals to a, that is all the variables here to be equals to a, so we'll be left with a minus di over 1 minus b. We should note that a here, this a here is representing a plus I naught plus g naught plus x naught minus m. So therefore we are left with a minus di over 1 minus b. So if we factorize 1 over 1 minus b out, we'll be left with a minus di. So this 1 over 1 minus b simply represents the income multiplier of the IS curve. The A here represents all autonomous components in the model, like I've explained, and this D here represents the sensitivity of investment to a change in interest rates. So thank you for listening. Please do not forget to subscribe to our channel and hit that like button. Thank you.